Hey everyone, welcome to yet another episode with Akshay and Shagun. My name is Partharu and I am Events and Program Manager for Microsoft Reactor India. I welcome you all for this session. Uh, but before we start our session, let's go through our code of conduct. We all are here to learn together, participate together. So please be respectful of other people's views, understanding their differences. Be kind and considerate in a way we all engage. Yes, we do encourage you all to participate. Please drop all your questions in the comment section. And now I would like to bring in Akshay and Shagun for today's session. Hi Shagun. Hi Akshay.
Hey, hi,
Hope you all are
Parth.
doing great.
Hi, Parth. Yes, all good. Thank you.
It's always at this time you folks are at office and this really gives a very good vibe for our audience to go with the flow.
Oh, great. We are glad then. Cool.
Yes, let's not wait the time more. The floor is all yours. You can get started. So who's going first today?
Yeah, it would be me again. I'll go.
Great. Great. So yes, Akshay and Shagun, the floor is all yours. I'll keep Shagun at the backstage. Oh, sorry, I'll keep Akshay at the backstage for a while. Yeah,
Definitely.
great.
Okay, welcome everyone. I'll just start sharing my screen. And here we go. So, yeah, thanks for joining us. So, as per the agenda and the topic here, multi-modal AI experience with Azure OpenAI service using semantic kernel, we will see how we can achieve that multi-modal experience with Azure OpenAI service, right? So when I talk about multi-modal AI, it talks about dealing with multiple data types, multiple
Hey Shagun,
modalities.
sorry to jump in between.
Mhm.
Sorry to jump in between. Can we have a
Yeah.
quick intro of Akshay and Shagun?
Yeah, definitely, sure. So yeah, myself, I'm partner technical consultant here at Microsoft. So my daily job is working with Microsoft partners, basically helping them with designing solutions, evaluating their architectures, or if they have any technical queries they are dealing with, they can anytime reach to me, and I'm there to assist them with their queries. So that's part of my job, which I really enjoy. And over to you, Akshay.
Hello, everyone. Sorry. Hello, everyone. My name is Akshay, and I am a software engineer too in the Azure Copilot team. My day-to-day job, includes creating copilots for different Azure services, and playing around with Azure OpenAI service, semantic kernel, and other SDKs. So yeah, Shagun, let's get started.
Okay, cool. So yeah, guys, we'll start with the session. If you have any queries, feel free to ping us here in the comment section. So yeah, I'll start. So as I was talking, right, we'll be have to deal with multiple modalities of data, and we have to learn how we can utilize LLMs, AI models, to process multiple data types like audio, video, images, text, right? So multi-model AI experience is when one model is dealing with each data type. But since we don't have any such model right now with Azure OpenAI service that can leverage every data type, so we'll see how we can achieve that AI experience, right? That multimodality part of it. Yeah, moving on. That's what we will be covering in this particular session. So this is what will be our today's agenda, starting with text to text, audio to text, and image to text, and then video to text. So text to text, we will be using GPT-4 a model of Azure OpenAI, and for audio to text, we will leverage Whisper model. So Whisper model basically is available via OpenAI service as well and via Azure AI speech service as well. When to use which model via which service, we'll discuss later soon as part of this agenda, this session. Moving on, image to text, GPT-4o again. So Azure's GPT-4o model comes with support of text and image. So we don't have to do any extra processing. There is no extra overhead to deal with image type of data. It supports both text and image analyzation, right? Then moving on to video to text. So there are two approaches that we can consider for video to text. Right now, there isn't support for video format in GPT-4o model, but we'll see how we can leverage GPT-4o model for video to text, basically, and how the second approach, video indexer, here can be leveraged to achieve the same, and when to use which particular approach in which scenario we'll discuss in this particular session, right? So I'll start. I won't take much time of yours here discussing the agenda, starting with our first topic, that's text to text. In my previous sessions, we have discussed a lot about text to text, that how GPT-4, GPT-4 model, we as a user input something, a prompt of ours in a textual format, and GPT gives us a response, a human readable, presentable, in a presentable format, a response to us, right? So you can refer to our previous sessions for that, and just giving a little review of what we did in the previous session, so that everybody of us here present in this session are on the same track. So this was what we discussed in our previous session, where we used AI search service, right? AI search service in a RAG approach, where our internal data set, our data files were present in blob storage, right? And we were indexing it using AI search. So AI search here was vectorizing your data. So you might be aware about text embeddings, right? So what text embeddings is, like, you have cloud, you have virtual machine skill sets, or maybe Kubernetes. How when you're sending your prompt, your AI search vectorize that particular data, so that it knows that these particular keywords are relevant to each other. It's something beyond keyword matching. It's not like cloud is equals to cloud. No, it knows that cloud, VMSs, virtual machines, Kubernetes, networking, everything is clustered together, are relevant to each other. So this is where actually AI search comes into picture. We'll discuss upon it later more, but yeah, it was just to give you a little review of how text to text can be approached, and you can look into our previous session for this particular part of the topic. Now moving on to different data types, that is audio to text using whisper model, right? So Azure OpenAI service also provides you with this particular whisper model. So this whisper model is also present in Azure OpenAI and Azure AI Speech Service. So, when to use which service is a common question, right? Since we have redundancy over here. So, I'll just share this particular document. And if you see my screen, you will notice that whisper model with OpenAI service is preferred when you want to transcribe your audio files one at a time, right? So if you see over here, the whisper model OpenAI service is only recommended when you want transcript or your phone calls, your meetings, right? It's not recommended during translation, right? So if you have some audio language you want to translate, then which Azure AI speech model is recommended. So if you have any larger audio files, maybe larger than 25 MB, then AI speech comes into picture. In translation, AI speech, right? You have to use whisper model via AI speech. Right? We will soon see a demo of it, that how we can utilize both of these services, like whisper model via OpenAI for transcript part, and whisper model via AI speech for translation part, live translation part, which is recommended approach. So you can refer to this talk, like there are multiple things, like you can use this OpenAI service whisper model for quickly transcribing your audio files, right? Or you have a pre-recorded audio you want to translate, but it's not recommended when you have your live audio, like translation of your live audio, right? It's not available with the OpenAI service. So recommended one is the AI speech one. So yeah, this was little theory part. I will pass on to Akshay to just start with the audio to text, and then slowly step by step we'll move to image to text and then video to text. Yeah, over to you, Akshay, for the audio to text part.
Thank you, Shagun. That was really great. Right. I hope my screen is visible. If not, Parth, could you please share that? Okay, perfect. Thank you. Okay. So I'll be walking you through the audio to text, code that we've written. I've already. You should see the link in the comment section soon. That has the code for the audio to text. And the other experiences that we'll be talking about today that Shagun mentioned in the agenda, right? So if you'll see, we'll be using semantic kernel here for interacting with the LLM, right? It's an open source SDK, and I hope it's most of you are familiar with it, right? So we'll be using the chat completion and the audio to text here, right? The packages, and what we have done is we have created a class, right, called audio to text. Then we have the function that will hold the code for converting that audio to text, and we will be using an audio file here that we will be transcribing using the Whisper AI model. Um, this is the file. I'm not sure if you guys can listen to the audio. Is it audible? Uh, okay. Okay. If you have,
While sharing, it asks the option to stream with the audio.
okay. Okay. Let me do that again then. I'll stop the screen share and then share again. Just a minute. Okay. Yeah. Okay. Now it should be audible, right?
The
This is
sun
the audio.
rises in the east and sets in the west. This simple fact has been observed by humans for thousands of years.
We'll be transcribing this particular audio. It's present in the assets folder if you go through the GitHub link that has been shared already, right? So what we'll be doing first is we'll be creating a kernel. As we all know, the kernel is the heart of semantic kernel, right? It's the base that holds all the services we want to use, be it plugins, be it different services called audio to text or the chat completion, image to text, etc. Right? We'll be adding the OpenAI audio to text service here. We'll be using the Whisper model here. It goes, the deployment model name. Then we have two environment variables that I've set. It's the endpoint and the API key that you can set while you create a resource in the Azure OpenAI, right? And then we build our kernel. Now our kernel is ready with the audio to text service, right? Now, what we'll be doing is we'll get the the required service, which is the I audio to text service, right? Store it in chat. Now we'll just start a loop. If you want to have a what do we say? Multiple files that we want to try transcribe, we can create a loop. Otherwise, we can just have like if we have just a single audio, we can remove the loop and then just go along with the code. Now, when we'll run it, the first thing it asks is where is the audio file located? Since we have to give it an audio file so that it can transcribe, we'll be giving it that. I'll run the code in a little while, right? Let's run it side by side. It will be easier to follow, right? Okay. So I'll just expand it a bit, right? Okay. So it asks me, 4 options. We'll be going with the third one for now, as that's the one we are showing right now. It's asking me the audio file located. It's in assets slash test underscore audio dot WAV, I believe. Yeah, okay. It'll be now, once we enter this, it stores the audio file. And then, in the audio file path, it just stores it. Next, what we are doing is we're opening that file, right? And once we open that file, we are storing it in the binary data as a binary data so that we can pass it to our Whisper model for it to transcribe, right? And then we create an audio content class. Now you will see this very commonly while we go through the different multimodal experiences. even in the image to text thing. Now, since it's an audio content, we have the audio content class, and then we create an object of it. Similarly, we will have it for the image as well, right? I'll show you that later on. We are passing the audio file and the MIME type as null. In case of images, we'll pass it as JPG or PNG, right? After that, what we are doing is we're getting the chat content. Since we passed it in the history, right? We got the required service, and we are now getting the text content async, and we pass in the audio content that we created here. Once we pass that, this particular object will hold the transcribed data, and then we just print it, right? I'll show you how it worked. We listened to it. It was something related to sunset, right? Let's run it and see what it gives as the output. Okay, yeah. So this is the output that it gave. It's the correct transcribed data, the text in output here, given an audio file, right? And it just asks us if we want to transcribe another audio. We'll just say no here, exit the loop. Now, in this case, if suppose we want to ask questions, it's a very large file, right? And then going forward, we want to ask it questions like about the audio. What we can do is we can just after this, we can just hook it up to our GPT-4 model or the GPT-4o, pass on the audio content to it, right? The one that came in as a text, and then ask questions to it later on, right? This is how it works, the transcribed thing, right? And as Shakun talked about, we can use Azure AI search, AI speech services as well for translation. I'll show you that as well, right? Just give me a minute. I'll wrap the text. Are there any questions in the chat before we go forward? Okay. No, we cannot use it without the key access. The Azure OpenAI requires a key and an endpoint created in the Azure portal, right? So unfortunately, no, we can't. Okay. Okay, let's go forward. Right. Now, here we'll be using the Azure AI speech for the tasks for translating the audio. And in this case, we won't be giving it an audio file, but I'll be speaking through the mic, and it will capture that and then translate it to French. I'll show you how it does that, right? Same thing, we'll be using the Azure speech, AI speech libraries for it, right? We create a function, and here we create our speech config that we get from the speech service that we'll create in Azure portal, right? We say, get the speech API key and the region. It automatically handles the endpoint, right? Using the speech API key and the region. Now, we are giving it from language. I've given it English. That's what I'm comfortable with speaking, right? And then the two languages that it needs to translate to, right? And I've given it as French here. And then we just give it the recognition language is from, since it needs to recognize that language, right? It's English. And the target language, it's to, right? So it will translate it to French. Now, this is the voice name. There are different voices available. I've just used the header voice. There's area, etc. Like we can check that in the documentation. Now, this is the translation recognizer. We are just creating it based on the config that we passed, right? The from and to and the voice. We just give it as the options here. Now, this part here, what it will do is it will capture the audio that I'm speaking through the mic and create an audio file as well, so that you can listen to it, the translated audio, right? So that we can listen to it later on, or if we need to share it, right? And then here, it's just this simple thing, right? It's the loop. It asks us like what language, the to language, right? And then here it recognizes my voice. This is the function that recognizes my voice when I speak. And then the result is the recognized text that it translates, right? So let me run this and show you. Let me clear this console. Okay, it's the speech translation. Hi, welcome to the reactor session. Okay. And if you can see here, it translated it to French. Right? I don't know how to speak it. Maybe Shagun, if you can help.
Yeah, right. Oh, okay. So yeah, it's correct. It says bonjour, bienvenue à la session du réacteur. Yeah, it says hello everyone, welcome to the session of reactor. And I think that's what you said. Cool. We are good then. That's really great. It's able to translate live what you're speaking. And as we discussed, it's one of the functionality of AI speech service. And yeah, it's great.
Perfect. Okay. It also created an audio file for us. Let's listen to it.
Bonjour, bienvenue à la session du réacteur.
Right. It's the same thing that Shagun said, right? In a more robotic voice, maybe. Cool. Right. Let's go forward and we'll talk about the image to text now. Right. Okay. Cool. Okay. So well, let's look into the other aspect, right? The other format of input that we can pass to our GPT models, to the OpenAI models, and it's the image, right? So this will convert our image, the image that will pass to it. We can either pass a URI or an image, and it will, get the content of it. We can ask it to summarize. We can ask it other questions, whatever we want about that image, and it will answer us, right? We'll see a cool example in a while. So same thing that we did before. We are creating our kernel using the GPT-4o model this time and the chat completion model, right? We created the service. Here we are getting the chat completion service because that's what it needs, right? To interact or to complete the chat, to generate the text. Now, what we'll be doing is we are starting a loop here so that we can ask multiple questions about this image, or we can pass in a different image and ask it to answer. Right. So we are starting the chat here, and we create a history. The history is say giving a memory to your GPT model, right? So that it has that context. So if you have used Chat GPT, right, in that particular session, if you give it something, it kind of stores it in the memory, right? If you say, "Hi, I'm Akshay," it will store it till the end until you clear the history, right? This is the same thing that it does. We're just giving it a system message. So by default, it takes a system message, which is you're a useful assistant that helps us to answer questions about an image in a single sentence. We can change it, right? We can remove the single sentence. It will answer in a different way. Now, um, the same thing that I talked about before, right? Since it's an image we are passing, we'll be creating an image content instance, right? Before we created the audio content instance. Now it asks us for the image URL. Now I have gone with the image URL option. We can, very well definitely go with the image path as well, like we did with the audio before, right? It asks us for the image URL. Let's run it, right, side by side so that we can see it as well. Okay, right, it's the image to text. Wait, let me clear the terminal. Okay, so I'll just give it image to text. It asks for a URL. I'll just give it a URL from my other screen. Right. Okay, now I've given the URL, right? It stores in that image content instance that we created of the image content class in the URI section. It knows now, okay, I have to use a URI, right? I have to fetch the image from that URI. Now it tells us, like, what do you want to ask about the image? Let me show you the image real quick. It's a simple, you know, verification type code that is there, a simple UI, right? Written in HTML, CSS, maybe, right? Let's ask it the question, like describe the image, maybe. Hmm. Okay, it says, it shows a mobile verification user interface, prompts user to enter a code sent via email, submit button and a numeric key, all those things that we wanted it to do, right? Now, how it did it is, it asked us what do you want to ask about the image. We gave it describe the image here. Now it is creating a collection item since we need to pass the text as well as the image to our GPT model, right, to the GPT-4o, so that it has both text and image to comprehend. We are creating a collection which is called a chat message content collection, right, and we are adding it as a user message to our history, right. Now, as soon as we gave it that, it knows, okay, this is a user message, this is a user prompt that came in, right, and then we are running, using the service that we created. We are getting the chat message content, right, the last message that it displays, and then we are exiting it. We are printing out the output, and then we're exiting. Let's see, what else it can do. I'll just say no here. I'll remove the single sentence, and let's see if it can, you know, write the same. It can recreate the UI that we just saw. So I'll do a .NET run, image to text. I'll just pass in the URL again. Ask it, give me the HTML code for this. Let's see if it's able to give it. Okay, here it gave a simple HTML and CSS to create a verification model. Let's see if it's the same or we'll need to tweak it more. Okay, just copy paste here. Right, I'll save it. Just call it demo.html. Right. Okay, it gave us a simple HTML and CSS. Not bad, right? For the demo, for the code. Perfect. Now, okay, so this was the image to text thing that it did. It used the GPT-4o model. And now, Shagun, would I take over and show them how to, do a simple video describing thing, a video summarization?
Okay, thank you so much, Akshay. It was a great, basically, demo that you showed that how we can leverage audio and images. And as we saw, right, that text and image were kind of a support that was available with GPT-4o model, right? And in our audio, we utilized two services: AI speech services and also OpenAI service, Whisper model. We used here. Now, moving on to video part, right? So there are different aspects, that two approaches that we can use over video. First is using GPT-4o model. I'll quickly share my screen over here and I'll show you what I actually want to convey. Okay, please let me know once my screen is visible. Yeah, cool. Yeah. So, as you know, GPT-4o model, talking about the first approach, supports image, right? So, the first notion that comes into our mind is to divide video into multiple frames, multiple images. And that is where basically this particular first approach comes into picture. So there are some kind of restrictions with this approach, right? Our video might have some audio, so this approach won't be recommended in that particular scenarios. And the another thing is our video might be lengthy, so that's the another thing that might create a restriction while using this approach, because when creating a frames or multiple images out of video, the audio is not captured, or when the video length is extremely great, how many images or frames we need to create, that's also a key aspect. Because here in this particular code, we will generate some fixed frames, right? So we have to be very particular that we are capturing keyframes, emotions, everything, right? So talking about the first approach is only recommended when it's a small GIF, small video, maybe with no audio, right? And we are looking for some general content. So I'll start with my first approach, and as Akshay have already explained how to leverage image part, right? So it's nothing. The first basically the first context here which you can see is dividing your video into multiple frames. So if you see console.write asks where the video file is located, right? And then we have the video file path that it's taking into picture. Output directory basically is the directory where your frames are being stored, right? So now again we have taken into account our video file paths, right? And this is basically nothing. It's like we might have variable length videos, so we are creating a logic to divide our videos in a way like into frames, like only one frame is captured per second, right? So once we have we know how many frames we want our video to divide, we are creating a simple for loop, right? From 0 to total number of frames. Once we have that for loop, what we are doing is we are creating those frames, and if you see here in the output directory, we are storing those frames, right? We are uh, like if you have 10 frames, this is a directory, local directory where you have to store my frames, right? So this is what this piece of code will do. And then afterwards, similar to what Akshay explained in the image part, right? Here, instead of image summarizer, I'll take as a video summarizer task. Again, I have my kernel builder, which is the base, and I'll add my services which I want to use. So here, the service that I want to use is OpenAI chat completion service using GPT-4o model endpoint, and again the API key. So I saw in the chat there was a question that they want to use a general Azure key or something. No, we need to be very specific about what key we are using. Whichever model you are using, you have to use that particular endpoint and key. So this basically is necessary from security perspective, so that only authorized users are using your model, right? So I'll show you, like if you are not aware, how to basically fetch your key or your endpoint, right? And then okay, moving ahead, we have added our service, we are building our kernel. Once again, we have built our kernel, we are creating a object chat and calling the required service, chat completion service, for conversational format. And then we are creating a history object, right? So history object is something that any message that we are passing on to this particular history, our LLM is aware that I need to process it. But this particular message, if you see, if I just scroll over chat history, it says talks about a system message. So the system message is a message that makes aware your LLM what it needs to do. It's an instruction that you're passing to your LLM. So we are passing here that you are useful assistant. You have to analyze a video frame by frame so that it knows what role it has to do, and it needs to answer concisely and directly. So you can modify this instruction as per your convenience. Again, then we are entering a while loop just to create a conversation, right? Conversation chat kind of a scenario. We are starting with a for loop again, right? We are creating a collection item, right? And passing on each of our frames to our history, right? So as you said, first frame, it knows I have to process second, third, fourth, fifth. So it has got whole of the history, whole of the context. And now when we are out of this particular for loop, we can just ask it, what do you want to ask? As a user, I might enter my prompt, and then it will augment my prompt with the frames and with my user query, and will provide me with the output with this particular result, right? That I get chat message content, right? Now Let's see basically what kind of video I'll be using. I will open it to the side. It's just a very simple video, a chess clip. As you said, the video, as I said, like the video needs to be very short because we are creating frames out of it, right? And if we have a lengthy video, it might hit a token limit and the performance might be very slow. So it's not recommended in those scenarios, right? And yeah, so this is the video. Let's just try our service. Okay, so I'll go with two because we are focusing on video to text, right? So where is the video file located here? I'll give my relative path. Just a second. Okay, I'll expand my window. So it says what do you want to. So as I said, this particular approach is for a general content purpose, right? Because it doesn't have it's not capturing the audio sentiments and all these things. It's only dividing into frames and then uh, basically analyzing it. So I'll just say summarize the maybe key points in video, right? So it totally depends from scenario to scenario which approach to use. So if it's not a very complex scenario, maybe you can go with this particular approach, right? So if you see, the Copilot says that it knows it's a frames, a sequence of images that is being passed, where one player is lifting and placing the white queen, and then subsequently the other players are coming into picture. So this is first approach, right? So this might not be suitable to every person, correct? Because I might have very lengthy videos with audio, my tech conferences, my meetings, which I want my Copilot to utilize, right? So now moving on to the second approach, which particularly uses Azure Video Indexer. So if you see in your Azure portal, you will find something like this of UI. I hope my screen is very well visible, right? So yeah, so this is what Azure AI Video Indexer is, right? It will index your video. That is, uh, let's take a look. I have these two videos. Let's start with first video of mine, right? So let it load. So once I upload this video, right, you see there are multiple text that it is showing. There might be multiple speakers, right, that are part of it. If I generate captions, if my audio is not shared, if you see there are multiple uh, text, images, audio, multiple things are involved in this video, and I want my Copilot to, capture each of this. So here the video indexer comes into picture. What it does, it kind of indexes into a structured format, so it generates insights. So if I go to download option, once it indexes this video, and let's take a look at the index file it has created. So if you see, there are multiple components. Yeah, okay, so this is the video ID. And then if you see the transcripts, it is capturing the audio, and it has somehow structured all of our video into a particular JSON format, right? For our LLMs to consume, right? Now, tech companies, these are the key features. It's a very intelligent tool which who knows what are the key points, right? Now, along with these particular things, if I go a little bit down, it also captures the metadata, like which part of the clip is talking about this feature, right? It also captures the things, it objects it is detecting in a video. News, it detected news, it detected somebody shopping, right? So these kind of intelligent feature, if you want to leverage, you have to go with AI Video Indexer, right? So if you see, this is a very long file, right? It's a very lengthy file that it has created. So passing this particular file directly to my LLM would be kind of a concern here. Again, token limit comes into picture, because I might hit my token limit that, okay, this is a very huge part of text, and then we also have to add our own query, which might not be a feasible approach. So soon I'll share this link in the chat window. if you look into this particular architecture, right? So what it is doing is, this is the video archive where I am uploading my video. This piece of code will follow this particular architecture to consume your video content and then help you providing solutions or responses as per your input. So what it is doing is, there are multiple components involved here: AI video index, AI search, and your console application or your web application, and Azure OpenAI service. So let's start one by one. OpenAI service is again whichever models, GPT-4, Whisper, DALI, and multiple models are available with OpenAI service, right? Then we have AI search. As you know, AI search is a very intelligent search service. So what AI search service will do is, like, it will embed your data. It has multiple skill sets, right? It can do key phase extraction. You can add your custom model to it. So it makes basically your metadata searchable. So I have this big structured data that is made by AI, like video indexer. It's not searchable. I want my LLM or my user to make it searchable. So that's where AI search comes into picture. So once my data is indexed, the prompt content comes into picture and AI search comes into picture. What's prompt content? You might be wondering, right? So prompt content is an optional part in this particular code that you will see and you can use, right? So prompt content is like, my video is related to AI and multiple speakers are talking on multiple topics, right? But I, as a service provider, is only focusing on students who are studying AI. So prompt content is something which will fetch only the part of the video which is important to us, right? So I might have 90-minute video, but the 20-minute video would be present in different parts, right, where AI is talked about, right? So it will only pass that particular part of video to my AI search. It's basically refining your video, that irrelevant data excluded, only relevant part of video pass it to AI search, so that it can vectorize it or make it more searchable. So now there are multiple benefits to it. Firstly, you won't be getting any irrelevant data. Secondly, uh, this approach helps you to, fast your process with the performance part, right? Right. And then also, again, it's very beneficial when the limit is there, token limit is there. You won't hit any token limit because the LLM or the query knows which particular part of AI search or data to query, right? So as in the RAG approach we discussed, once the indexed data is present in AI search, it's normal. The through web application user queries and it goes to AI search. AI search augments your prompt. It's like what is present in the video, and then it knows that, okay, tell me where the AI key points are listed. It will go to AI search, augment your query, and then give it to OpenAI. OpenAI will convert it into a more human representable format, more readable format, and then response is passed on to the user. So only one thing, single thing, which is different from text to text is, which is basically AI video indexer, because AI search can only take textual format. It can't take video format. So we have to index that data. We have to convert the video into a structured JSON format, a text format, so that AI search can consume it and we can make our data more searchable. So we'll respect the time limits. We are out of our if you want us to explain this part of code in our maybe next session, we'll go into it. But yeah, this is basically the flow that works over here. You can take a quick look in this particular GitHub link, and if any questions, feel free to pose, right? And yeah, just talking about this OpenAI service, right? If you are wondering where to fetch the key and endpoint, you have multiple models, right? To consume. Suppose Whisper model. Once I click on Whisper models, I have my key and the endpoint that I want to, utilize. So you can get your key and endpoints from here. So yeah, that's all. feel free to ask any queries, or if we have any.
I don't see any questions in the chat. Right.
Okay.
Yeah.
That's cool then. We have successfully kind of discussed how we can use multiple modalities, videos, audios, text, images, and have our own copilot. Yeah, over to you, Parth.
Fantastic. It was a fantastic session. I think there was a question earlier. How can we use OpenAI model without key access? So
Oh,
looping into similar
yeah, we
question,
answered both the
We
through
questions.
answered it.
default
Yeah.
Azure
Yes.
credential, can we access?
Yeah, it has been answered. No, we can't. We have to be very specific about the model and the key and endpoint associated with it, and we have to only use that. It's basically from security perspective that needs to be
Great.
taken account.
Final call to ask questions.
Thank you, Yusuf.
Let's call for a wrap then. We don't
Cool
see
then.
questions. Thank you, Yusuf. Yes, thank you,
And
Akshay. Thank you, Shagun. Thank you for presenting very beautifully, and I hope the audience is well educated today with our session. And please go through the links which are in the comment section, which will help you to take your learning further. If not, if you all have any other questions arise, feel free to reach out Sagun and Akshay over the LinkedIn. The LinkedIn links are posted over the event description. And
Okay,
thank you
cool.
all once again. Hope you all have a great evening. Thank you.
Thank you, everyone. Thank you, Parth. Yeah,
thank you,
good day.
everyone. Thank you, Parth.
Shagun.
See ya.
Thank you, Akshay.
Bye.